I click record. Okay. So good evening, everybody. Tonight we're going to take a look at doing some basic tidal calculations. We're looking at being able to correctly calculate the right hour of tide. This leads on from what we did last week, where we looked at estimated positions and we looked at course to steer, and I gave you the tides. We were working on the navigation principles there rather than correctly calculating the tides. And we're going to have a go at using some worked examples that I have done. So I might be asking you some questions. If you've got a piece of paper and a pen handy, there might be some questions as we go for you guys to calculate. You can either work it out longhand or you can pop it onto the chat as well. Let me just pop, there we go, pop somebody else in, okay. And the intention is it's around about 40 minutes. I'm going to try and make it as exciting as I can. It isn't the most exciting of subjects, and this is really one of those subjects where I go to town drawing in different coloured pens on a whiteboard. So given that I don't really have the whiteboard, I know I can use the whiteboard functionality, but I don't have the same kind of ability to draw on the whiteboard and draw lots of colours around it. I've had to put a couple of slides together to show you how we go about doing it, okay. So what I will do is just resume recording. Okay. So tonight's session then, like I said, we're going to be working on tidal calculations of getting the right hour. Some people say it's a really easy thing and that people should really know how to do it. And I'm thinking, well, it depends on how you've been taught, really. So there's some really simple calculations and some really simple rules of thumb that you can use in order to do it, particularly to understand where we've got different time zones and where we get the information from. So we're going to run through some slides, give it about 40 minutes. For those of you who don't know, who perhaps are new to the sessions, I am Kath. I am the chief instructor here. I am a shore-based instructor. I'm also a Yachtmaster Instructor Power and a Advanced Powerboat instructor. So I spend quite a lot of my time teaching tidal calculations at various different levels. I'm aiming this at around the day skipper, so the essential nav and day skipper level. The secondary port session again on Tuesday, I'm going to aim that at around the day skipper level, perhaps a little bit more. So hopefully, you fingers crossed, you can keep up as we go through the session. Okay. So what are we going to have a look at doing? So we're going to have a look at the Almanac entries for standard port. We're going to look at the red spring tides and neap tide entries then. So what the red days and the blue days mean. How we can use the tidal curve to determine the spring and the neap tide. So how do we work that out? Where do we get that information from? Universal time, daylight saving time. We'll talk a little bit about time zones because that's one of the things that I find really gets a lot of students in a pickle. And calculating the right high water hour, and then how we select the right tidal rate and set from a diamond, a tidal diamond, or an atlas. Okay. So first up then, what I am going to do is I'm just going to pop a poll up to see how you guys feel about tides. So what I am interested in. Okay, so that's tonight's objectives then. So where are we going to start? Well, first up, we need to know why it's important. Why do we even need to be able to calculate the right tidal set and drift? Last week, we looked at our EPs and our course to steer, and actually, as well as being able to do the magic calculations from compass to true and so on for our ground tracks and our water tracks, depending on the activity, we need to be able to go away and get this tidal set and drift from the right place, okay? So let me just pop a couple on, bear with me. So it's really important that not only can you do the fixing, that you can work the EPs out, that you can actually go and get the right tidal set and drift, okay? And it isn't a particularly complicated thing, but actually just a few little tips and tricks will make it a lot easier for you, because we could be drawing these tidal diamonds, tidal sets and drifts here, where we're perhaps looking at it being a 1 hour question. Okay, but actually, realistically, do we really go sailing for 1 hour? So we might need to also think about, what if we went for a longer trip? What if we went for a shorter trip? Okay, so we need to work out how we can actually get the right one for what we need to do. Okay, so where do we start? Well, let's have a look at where we get the information from a starter for 10, okay? We're going to get our information from our almanacs, and I've got a range of information on here for you. So this is an extract from the RAA Training Almanac. We're going to be using that in just a second. I've also got an extract in the middle here, which is from our Reed's Western Almanac. This is looking at the tidal stream data for the Bristol Channel. We've got a tidal diamond set here, and this is an interesting one. This is off one of the IMRE charts. I think this is off a C61, if I remember rightly, which is the northern half of the Irish Sea. And what you can see here is that we've got our tidal diamonds, and this top one here is based on high water at Belfast, but these B and C here are based on high water at Liverpool. So it's really important that not only do we know where the information is, but actually which is the standard port which we need to go to get that information. Now, in some of the almanacs, what you will find is that it's all referenced to Dover. Dover is the standard port for UK. And actually, you can't quite just make it out here, but on this one here, for the reads, it actually says this is 5 hours before high water Dover, and it's at high water Milford Haven. Okay, so it's important that you understand where your tidal stream atlas or where your tidal stream, your tidal diamonds are referenced to. It will tell you on your chart, or it will tell you underneath it on the tidal stream atlas here. For those of you who get the Western Almanac or the Channel Almanac or even the Eastern Almanac, you'll find that it has this little sort of bookmark, which is Dover Tides. Now, a lot of my students on the West Coast say, well, I'm not interested in the Dover Tides, and they just throw it away. They don't realise the importance of it. A lot of the information in the Almanac is referenced back to Dover. Okay, so that's the standard port that it's all referenced back to. When we deal with the RYA training charts, chart 3 and chart 4, and the RYA training almanac, our standard port is called Victoria, and that's this one up here. So everything about our tidal diamonds, so if you're working on Day Skipper or you're working on Yachtmaster, everything about our tidal diamonds or our tidal stream atlases is referenced back to Victoria. So it's really important that we know where to get that from. Okay, so if I just pause the share here and go to here, and if I click resume share, resume recording. So here we're taking a look at the RYA training almanac, and really it's just to give you an idea of the information. So under a standard port, this is an entire entry for a standard port. So we would get the description, the pilotage notes, tidal streams and heights, information here around the standard port. We also get the location of it. We get a chartlet to show us what the port looks like. We also get an entire tidal entry. So we have everything from January all the way through to December. And if I switch through the book, then you can see May, June, July, August, September, October, November, December. Okay. We've got some shaded areas and some non-shaded areas. Our shaded areas are winter time. Our non-shaded areas are summertime, but our almanac is written in UT, so that is the winter time, if you like, universal time. So for you ones in the UK, they would be written in GMT, so that's our universal time, and then in the summer we have BST. So effectively we have the two time zones between what we see in the winter and what we see in the summer, but there aren't any corrections in your almanac for summertime. Okay, and that's quite important when we come to one of the examples. We're also going to use the tidal curve, but not from a tidal curve perspective of putting the lines on the charts. What we're going to do, if I can just bring it down, is we're interested in this little box here, which is at the top of our tidal curve, which gives us the mean ranges. Because for everything that we calculate, we're going to need to know whether it's a spring day or a neap day, because our tidal curves and our tidal atlases are done for average springs and average neaps. So we have to take this information along with, if I just flick back through, if I come back to there, if I flick back through, as well as the information that we're going to get for each individual day. And I'll pull some of these out in a second for you to have a look at. Okay, so that's our standard port entry. And for everything that we do on the RYA training plotter, we use Victoria as our standard port. And we know that because it will tell us on the atlas. If I quickly zip back, you can see here is an extract from the atlas, and it's saying 5 hours after high water Victoria, and that is true no matter where we are on this chart. So although there are other standard ports, so Port Rampton is a standard port, we've got Hamilton, for all of our tidal calculations, we take them all back to Victoria, in the same way we would take them all back to Dover in the UK, no matter where we were. Okay, Zoom recording. So this is the different information that we can get. So we can have our tidal diamonds, we can have our tidal stream atlases, but we also need to be able to go and calculate what day it is. So what I've done is put together, let me just put someone in, there we go, is put together a little bit of a checklist for you, because everybody loves a checklist, okay? So if you want to calculate a tidal vector, you are going to have to calculate all of this information in order to get the tidal vector. So we need to know which standard port we're using. We need to know what day it is, which time zone we're operating in, whether it's which is our nearest high water time to our plotted position. So if we are sailing in the afternoon, is there a high water close to our afternoon sailing time? We then need to calculate whether it's springs or neaps. Then we need to calculate our tidal sawtooth to make sure that we get the correct hour, and then get our information from the tidal diamond or the tidal atlas. And that sounds like quite a lot of information. But what I'm going to show you is a couple of examples where it's all on one page. And the way I teach it is to draw it all on one whiteboard. Okay, so example number one, let's have a go. Let's say we plotted our position at 2030, and this is the tidal diamond that the tidal information that we want to gather. So we've got our water track on here, we're plotting our EP, and this is roughly going to be a 1 hour journey. So we fixed our position at 2030 UT, and it's the 1st of January. So universal time is winter time, if you like. The 1st of January, our standard port is Victoria. So back to our list then, what's the first thing that we need to know? Okay, let's go get the tidal information for that day. And what I do in the Almanac is I suggest, if we get this, you put a circle around the day. I cannot tell you the number of students who don't circle the day and then they go back to look at the chart, and when they come back to the Almanac, they choose a completely different day. So put a pencil circle around the day so that you know which day you are looking at, okay? So our standard port then there is Victoria. We've gone to Victoria. This is an extract from Victoria on the 1st of January, semi-diurnal tides, 2 high tides and 2 low tides. We're sailing in the evening, so we're going for a nice New Year's Day evening sail. We're sailing home, and we want to work out what the high water is going to be nearest to our time. But first up, we need to know, well, when we calculate this, is it going to be springs or neaps? And the mean ranges give us the idea that if the range between the high water and low water is 4.9, it's a spring day, and we use the spring rates. If it's 2.4, then we use the neap rates, okay? So what does the calculation look like? Our nearest high water to the time our boat is playing out is around 23:54 UT. Let's keep it simple, okay? Let's call it midnight. I'm not going to argue over 6 minutes. Let's call it midnight. So we've got a high water of around about midnight, and we do our range by taking our high water height, take away our low water height, because we are sailing sometime in between this low water and high water here on a flood tide. 5.6, take away 0.7, very handily gives us 4.9 meters, almost like I planned it that way. Okay, so this is a standard spring day. So whatever we're looking for, we now need to work out from our high water time of midnight, how does that relate to us? So our boat is going to sail from 20:30 to 21:30. So I'm looking for a whole 1 hour of tide, because I'm going to estimate my position at 21:30. So first up, and this is the first top tip, write down your high water time. So high water is at 000 UT. I'm a big fan of labeling everything, okay? So never put a time or a bearing without some sort of label. So 000 UT, and the high water page on the atlas, or the high water line on the tidal diamonds, is for 1 hour, call it the 0 hour, which means that it lasts from 30 minutes before high water to 30 minutes after high water. So the high water entry is going to be, in this instance, valid from 11:30 at night, so 23:30 out to 12:30 midnight. Okay, I do that before I draw any of the rest of the sawtooth, because I get that bit sorted. Okay, I need to put my 30 minutes either side so that this is valid for 1 hour. Then I can draw my sawtooth. Now I've made it look quite pretty. In reality, I would just draw it with a pencil, okay? It doesn't need to be that pretty. And what I'm gonna do now is put high water -1, high water -2, high water -3, down to high water -4. You can go all the way to high water -6, but we don't need to for this particular example. And now I can fill in the right-hand side. So I only ever put the times on the right-hand side of this sawtooth. So here I'm just adding on an hour, adding on an hour. So taking away an hour, taking away an hour, taking away an hour, and taking away an hour, okay? So what does that tell me? Well, it tells me that when I go and look on my tidal diamond, that the high water minus 4 hour is valid from 1930 to 2030. The high water minus 3 hour valid from 2030 to 2130. So because I've written this down at the top, we're sailing between 2030 and 2130. So I am very, very interested in this element just here. I am very interested in high water minus 3, okay? Because our boat is departing at 2030, looking to arrive at our estimated position at 2130. So we are interested in what did the tide do in this hour so that we can take it and we can pop it onto the end of our DR nav here. So now I need to go and get the relevant tidal diamond, and here's how the tidal diamonds work. It gives you a little bit of a clue next to it on the Admiralty charts. These are my high water hours down the left-hand side, everything from -6 through to +6. I've then got the tidal direction, and then I've got my spring rates and my neap rates, and we're going to read across the lines here, okay? So if I'm interested in high water -3, what I want to do is grab a line here. I want to draw the line under high water -3, okay? Because this is the tidal hour that I am interested in. But remember, we've got a tidal rate and we've got a tidal drift, and the rate I'm interested in, I did all the calculations over here, is a spring rate. So what's the numbers that I want to put onto my charts? Well, my tidal vector for high water -3 is going to be 297 degrees true, and a spring rate of 1.4. Not interested in the neap rate because it's not a neap day. Okay, it's a bit like red days and blue days on a diet. Okay, we're having a red day today. So now I can go to my chart and I can draw that on there. So if I pause the share, I go to my chart and resume share, you should hopefully all now be looking at my my chart. Okay, fab, thank you very much. Okay, so we've got our position that we fixed here at 2030. I've already drawn my water tracker on. I reckon this was going to take us about an hour. So I've done my calculation and I had high water -3 was 297 degrees true at 1.4 knots. So I'm going to go and get my tidal stream, and I'm going to draw it on here. I'm going to come out at about 297 degrees, roughly at 1.4 knots. Well, it's about there, okay? And then what I can do is I can take my 2130 UT and pop it on the end. So I have now calculated, if I just highlight that, I have now been able to calculate the correct hour of tide. If I wanted to, I could now calculate my actual speed over ground, and I can say that my EP at 2130 is going to be roughly there. So this tide has headed me away from where I wanted to go. Okay, so if we pop back to my calculations, okay, how did we work it out? We went to the right day, we worked out the springs or the neaps, we worked out our sawtooth, we figured out when we wanted our tidal vector to go from and to, and then we went to our tidal diamond and we got the right information, okay? And then we can plot it onto the chart, okay? So all happy with that process, because that's nice and simple when it's a wintertime question. What happens if we go sailing in the summertime? Because actually you'd quite like to be able to sail on a day other than the 1st of January. So this time we're going to be dealing in BST, so British summertime or daylight saving time. Okay, so what your watch is telling you. And now we have a bit of an issue because the standard port is still Victoria, but because we're in July, our almanac is no longer shaded, which means that this is written in UT. So there is an hour difference between BST and UT. Remember, in the springtime, we spring forward, we put the clocks forward an hour. So now what's really important is that for me, I draw them in different colors. So all of my BST times, I'm going to draw in purple. All of my UT times, I'm going to draw in black. And then I can see the difference, and you'll see why. So the ranges are still the same. We're still in Victoria. So I'm going to say, well, it's the 4th of July. Here's the 4th of July. I can put my circle around the 4th of July. There we go. put my circle around the 4th of July, and I say my nearest high water to this time when my boat is playing out at 2020 is going to be 1751. There's my high water there. But that's 1751 UT, so that's a bit of an issue because my almanac is a different time zone, if you like, to my watch. I'll work out the range because I'll come back to the time zone in a second. I work out the range, and this time, well, who knew? It's bang on a Neap day. Okay, so 4.3 take away 1.9. It's bang on a Neap day. Okay, and we're just going to use the Neap range. So my boat is actually fixing its position at 2020 BST. See, this is in purple. And we're going to do a 1 hour EP. So we want to be able to calculate our estimated position at 2120 BST. So what does that mean for the time zone? Well, it means that in reality, our boat is out at 1920 UT and 2020 UT, and the EP would really be at 2020 UT. So this is where you have a choice. Personally, I would say get rid of all the UT, write all your calculations in BST, because actually then if you change where you're going or whatever, all your calculations are done in watch time. Okay, and then you would look at your watch and you would be able to look at your calculations. So I say, all right, then I'm going to put a line through that. Okay, what I'm then going to say is, what does that mean then? So I can have my high water at 1850. I've knocked off a minute just to make the numbers a little bit easier. So now I'm going to draw my sawtooth based around BST time. And again, I'm going to cross out that. Okay. So when I draw my high water, I do exactly the same. You'll see down here. I do exactly the same. I start with my high water at 1850. I then do minus 30 minutes and plus 30 minutes. So I'm going to end up with my high water hour lasting from 1820 up to 1920. Then I can draw the rest of my sawtooth. Okay, so all the way up the page I go because I'm going high water plus. I can pop all my times in on the right hand side, and note these are all in purple and these are all saying BST. I've labeled everything. And then I've got high water plus 1, plus 2, plus 3, plus 4. So now I'm thinking, brilliant, I want to go and work out the tide for my boat being out between 2020 BST and 2120 BST. So just have a quick think and pop into the chat, which high water hour would you choose? Is it going to be high water plus 1, high water plus 2, high water plus 3, or high water plus 4? Alrighty, so if we're looking at 2020 to 2120, we need to start here and go to there because this is a whole hour. And one of the things that students get a little bit lost in is they look at 2120 here for the EP, they just go straight to 2120 and then they select the wrong hour. So all those of you who suggested high water plus 2, you are dead right. Okay, 2020 up to 2120. And we're going to grab our tidal diamond again. We're going to take a look at our tidal diamond, and in this instance we're going to take a look at our tidal diamond. We want high water plus 2, so I'm going to pop a little red line just underneath there for you. So this time we're looking for a tidal vector for high water plus 2 of 111 degrees true, and remember we calculated this to be Neap, so we're looking at 0.8 knots. This is an average Neap day. Okay, so what does it mean now? Well, for this one, what we can do is go back to our chart plotter, click resume share, and we can take a quick look back down here. Okay, all see the chart plotter? Good. All right, fabulous. So we've got our fix here at 2020. This time we were perhaps sat off the Alpha Juliet Delta platform, perhaps been watching the world go by, and we decided to sail back in towards Bramhope Bay. So we've plopped our water track onto there. Now we want to grab our tidal vector. So we've worked out our tidal vector to be 111 degrees and 0.8 knots. So I'm going to put 111 degrees on, roughly, it's not so easy to do with a mouse, but 0.8 knots. There we go. And by jingo, look at that, for an estimated position, we are pretty much on the entry into Bramhope Bay. Okay, I love it when a plan comes together. So now we've got our water track and we've popped our tide on the end. If we wanted to calculate our speed over ground, we could measure between the fix and the EP, and we would know that our estimated position, if this was our best course to windward and we were projecting this EP, say, best course to windward here, we would be absolutely on the numbers with an entry into Bramhope Bay. Okay, so we pause the share, pop up a new share. Let's just go back. Okay. So that works great. So we've done what happens if it's winter time, what happens if it's summertime, what happens if we only go sailing for 30 minutes, or if we go for a little bit longer. So if we go sailing, say, for 30 minutes, the initial one that we did was this track going in. Let's say we're on a faster boat. The high water is going to be the same. This one is still in January. The high water is going to be the same. The range is still the same, but this time we're on a slightly faster boat. And we're only going to take 30 minutes to do this leg. So actually what I'm interested in is the tidal vector that goes from 2030 to 2100 UT. But I still do exactly the same calculation. I go back, I get my high water, I get my range, I check whether it's springs or neaps, I take my high water and I pop it up at 0000. I do my plus and minus 30 minutes to make sure I've got the 0 hour sorted before I then draw my sawtooth. And this time what I'm looking for is 2030 to 2100. Well, 2030 starts here, but never quite gets there. So I'm interested in some of this high water minus 3 hour. Okay, but I'm interested in half of it. So when I pop my tidal diamond up again, I grab my line just to pop under high water minus 3. Okay, under high water minus 3 here. The fact that I only want half an hour's worth of tide is not going to change the direction at all. That's going to be exactly the same as it was because the tide will still go in the same direction. It's still a spring day, so I'm still interested in this spring rate. But now I only want 30 minutes worth. So I don't need the whole hour. I just want 30 minutes worth. So, oh, I've got a message saying I don't think you are sharing. Sorry, have I put the share up? There we go. Okay, pop the share back up for you. Thank you. So, ding, 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 where can we go back to? So, if we were doing a 30-minute plot, we can fix our position in exactly the same way. This time I'm interested in only 30 minutes. So, all of this calculation on the left-hand side here is exactly the same. You guys can see the slides now, yes? Fab, thank you very much. Okay, I'm only interested in 30 minutes. And actually this sawtooth here looks exactly the same as it did before. I've got my high water hour at midnight, I've done my plus and minus 30, and then I've worked the rest out. So going over to high water minus 3, I'm interested in high water minus 3. Let me put it on here. I'm interested in high water minus 3, but what I'm not interested in is all of it, but the direction is not going to change, but the rate will. So in this instance, although I've got 1.4 knots for the whole hour, I'm only sailing in half of that. So the direction is still going to be 297 degrees true, and I'm going to have 0.7 knots of tide. Okay, so if I pop back to my chart plotter and pop you resume share, okay, I definitely clicked it this time. So here we've got our fix at 2030. Let me just delete this one off, pop him up there. This time we're on a quicker boat, so it's only going to take us the 30 minutes. And what I need to do is I need to go pop my line on, grab my tidal stream, same direction, 297. So I'm heading out this way, 297, and pop out. But I'm only interested in, ooh, difficult to get. Oh, there we go, that's good enough. 0.7. Okay, so this time it's a half-hour boat speed and a half-hour tide, and my fixed position or my EP is going to be here as opposed to it was further up on the chart. Okay, so if I go back here, click resume share. So we did exactly the same calculation. We still had to write it all down, but actually we only took half of the vector. Okay, and similarly now, what would happen if we wanted to take maybe 2 hours? Well, we would simply select the one vector and then the next vector, and we would be able to draw them both onto the end of our EP. Okay, so that was a very quick canter through Almanac entries for standard ports. We took a quick look at spring and neap tide entries, looking at the red days and the blue days, using the tidal curve to determine the springs and the neap tides. universal time and daylight saving time. We had a quick look at a calculation that took, one was universal time and one was daylight saving time, how to calculate the correct high water hour, and how you can select the tidal rate and set from the tidal diamond and the tidal atlas. Okay, so what are the next sessions? We have secondary reports on Thursday. That's going to be an introduction to secondary reports and how you can do the calculations to create your new tidal curve for a secondary report and do a basic anchoring question. So have a look at how, perhaps what the clearance would be under the boat at a low water. We also, like I said to you earlier, do have the recordings, the EPs of the EP session and the course to steer session, and hopefully this session as well on our YouTube channel. If I